Hello and welcome. My name is Garen Stauble and I will be leading this tutorial on Spark 2.3 and Azure Databricks. I've been working with Spark since 2015 and have done a bunch of stuff in the big data space, so let's get started. In this webinar we are going to cover Intro to Azure Databricks, creating instances and clusters, importing libraries, notebooks, and data, as well as creating notebooks. Spark 2.3 features will also be covered because this is brand new, which includes image schema, vectorized pandas UDFs, as well as last but certainly not the least, stream-to-stream joins. Let's get to it. From our dashboard, we're going to go to All Services so that we can start to look for Databricks. Search for Databricks in here and see Azure Databricks comes up. In here, you're going to create your instance of Azure Databricks by clicking Add. Specify your workspace, subscription, resource group, location, and pricing tier. Then you're ready to move on. Now that we're logged into Databricks, we can go and see our dashboard, which is what you'll start with. Let's create a cluster. The name of unicorns. Databricks runtime version will be 4.0, so we have Spark 2.3. Python version of 3. Worker types stay the same, and Spark config is going to be default for now. Now we can see our new cluster creating itself. We're going to click on it so we can view the settings. We're good to go. Now that we have a cluster set up, we're going to go and import a library. To that, we go to our workspace, click the little down arrow, and click Import. Then we're going to click to import a library. There are 4 different types of libraries: Scala Java jars, Python eggs, Maven coordinates, and R libraries. Today we're going to use Maven coordinates. So let's use this handy feature Databricks has built in. Search for Spark-NLP, which is just a cool library John Snow Labs built. We're going to select it, switch over to version 1.4.0, and create the library. Now that it's created, we can choose which clusters to attach it to. So let's attach it to our newest cluster, unicorns. It's attached successfully, and now we can start using it. And you can see it here in the workspace. Now let's import the Gentle Introduction to Spark by Databricks' own Bill Chambers and Matej Zaharia, the original creator of Spark. Back in our workspace, we're going to go back to Import and the caret down, go to URL, paste the URL that I'll have in the comments, and here we go. Now we have the Introduction to Spark on Databricks by Bill Chambers and Matej Zaharia. We're going to expand out our workspace so we can see the actual name. We're going to rename this so it's just without the 3 in it because we don't like to see that. Hit rename, and voila. We now have our clone notebook on here. And what good is a notebook if you don't have data to work with? So let's go over how to import data. So let's start by going to the Data tab, clicking plus on the tables. Then we're going to populate this with some of the pertinent information, including uploading a file that's just a basic CSV file. Let's create the table with the UI so we can get a feel for how that works. Assign it to the unicorns cluster. Now we're going to preview the table. It's just going to read through and interpret the data as it is. We're going to tell it that the first row is a header. And we're going to click Create, and now we have our table created. Now that we've got some data to play with, let's go back to our workspace, and we're going to create a notebook. Let's call it Development using Python, and we're going to use our unicorns cluster. Once we create our notebook, now we're going to start reading in the data that we just created from as a table. So we can use the spark.table function, which I think is very cool. It creates a data frame for you, returns 1. And now we're just going to display it using the handy Databricks display function. And we have a look at our data. And we can view all of the columns and all their values exactly as they're stored in the table. You've made it this far. Now let's talk about Spark 2.3 features. One of those features is to be able to read images directly into Spark data frames. So here you'll see that I'm going to call the read images function, which is directly from image schema. This is going to create a binary image that's read into Spark in a way that Spark can understand and we can use later on if we wanted to. Now we're going to just select out the columns from the image struct, but remove out the data column because that just has binary data, and we can see all the channels, height, width, etc. Another huge new feature in Spark 2.3 is the introduction of pandas vectorized UDFs for PySpark. This greatly increases performance, as you can see from this chart. So let's go ahead and import this pandas UDF benchmark notebook into our Azure Databricks instance. Copy that link, go over to Databricks, go to import, select URL, paste it, and again we'll provide this URL in our comments. Once that notebook has been added, we can now click Run All, attach it to our instance or our cluster, which is unicorns in this case. We're going to hit Run All. It's going to run all the commands. I'm not really going to go through this, but you're free to look through this on your own. It's just the whole benchmark of how the UDFs work. It's pretty cool stuff, so have a look and learn some more about this. This is an awesome new feature. Last but certainly not least, one of the coolest new features in Spark 2.3 are stream-to-stream joins, where you're no longer limited to joining a stream to a static dataset and an expansion, obviously, of the static-to-static dataset joins. Now we can do stream-to-stream joins. Databricks provides this handy dashboard that shows us the input versus processing rate, batch duration, and aggregation state, so we can see how our state is growing throughout over time. Now we're going to cancel this query because this query is kind of a naive way of doing a join where the state will grow unbounded. And we're going to move on to the inner join with watermarking. Watermarking is optional for inner joins, but we're going to usually it's good to provide it because otherwise you can have infinite unbounded state growing in your inner join without watermarking. After fast forwarding a bit, you'll see we're at about 81,000 distinct keys. And now if you look closely at the aggregation state, you'll see that it starts to plateau. That's because our bounding from watermarking and the join criteria have taken effect, and now the old state that is now stale, per our definition, is going to be purged and deleted so that we can keep maintaining a consistent rolling window state over time as our stream-to-stream join continues to keep data that we specified in our criteria in memory to do the joins. The last part of stream-to-stream joins that we're not going to cover in really much depth are outer joins. Outer joins require watermarking, whereas watermarking is considered optional for inner joins and used really just to maintain state. Outer joins would not work without watermarking, which you can read more about here.